Matrix multiplication by hand. Matrix multiplication, that is multiplying two matrices together, can be a little bit tricky, but we do need to know how it works. The good news is you can do it on the graphics calculator easily. The less good news is you do need to understand how it works by hand to be able to use it to solve problems. So I'm actually going to start with a scenario, and I'm going to talk through the multiplication, but I'm not going to really tell you the rules. Please don't worry if you don't get what you should be doing right now. We're actually just focusing on the logic of, logically, what do I need to do to find out, in this scenario, this question. After that, having seen this, will make it easier for you to understand the rules and methods of matrix multiplication. So Tim and Tilly bought pens and exercise books for their classes. Matrix N shows how many of each they bought. So obviously Tilly bought 7 pens and 2 books. Matrix P shows the cost of pens and books. Pens are $1, books are $2, just to keep life easy. Now my aim is to find the total cost for each person and to do it with a matrix. It's quite easy for us to just logically work out the total cost for each person. Tim bought 3 pens. They're $1 each. 3 lots of 1. That's $3 that Tim spent on pens. Tim bought 4 books. Books are $2. 4 times 2 is 8. $8 for pens. Tim spent $3 and $8. Tim spent $11. But have a look at how we did the multiplication to get Tim's total cost. We did the first value in Tim's row, Tim's number of pens, multiplied by the first value in this cost column, the cost of pens, number of pens times cost of pens. Then we did, and I'll write that in here. So I did number of pens times cost of pens for Tim, 3 times 1. Then I moved over to Tim's books and I did the number of books times the cost of books. The second thing in Tim's row times the second thing in the cost column. Makes sense to do it. And I added that because I want to get the total cost. So I did 4 times 2. So that's the cost of Tim's pens, that's the cost of Tim's books. Then I've got Tilly. Tilly's got a row of her own. She bought 7 pens. Pens are $1 each. 7, the first thing in Tilly's row, times 1, the first thing in the cost column. 7 times 1. Pretty sure Tilly's going to spend $7 on pens. Tilly bought 2 books. Books are $2. 2 times 2. And because I'm going for the total, I'll add that. So the matrix of the total cost for Tim and Tilly, each person, 3 plus 8, $11 for Tim, 7 plus 4. Oh, look. Also $11 for Tilly. We did that by multiplying 2 matrices together. And while I wouldn't need to do it for a really small matrix, we learn with small matrices, but we apply it with big matrices. This is obviously applicable in very large computer sets of data. But you'll see that I did everything in the row times everything in the column and added it together. Everything in the row times everything in the column and added it together. And we got a meaningful output. So we need to learn and apply what we just saw to the rules of matrix multiplication. So the rules are, if I'm multiplying matrix A times matrix B, all rows of matrix A must be multiplied by all columns of matrix B, finding the total each time. So that's what I did here. I did the row times the column and added up what I got. The row times the column and added up what I got. In order to be able to multiply all rows of matrix A by all columns of matrix B, we've got to have some matching numbers there. This wouldn't have worked if I had another 4 things in this matrix, because there would be nothing in this row to multiply those by. So the number of columns in matrix A must equal the number of rows in matrix B. And the easiest way to think of this is if you write the order of matrix A and the order of matrix B, remember rows times columns, if I represent that as m times n, rows by columns, and represent B as n times p, rows and columns, columns in A, rows and columns, rows in B, they must, I'll get a better pen for highlighting, they must be the same. Otherwise, you cannot multiply the 2 matrices, and if you have a maths sum that has no answer, that cannot be done, our matrix product would be called, sorry about the space there, undefined. A matrix that a pair of matrices that I can multiply and get an answer, the answer would be defined, there is an answer. If these 2 are not the same, then there is no answer. You cannot multiply them. I say it's undefined, no possible answer. The third rule of matrix multiplication also ties into this, and I've run out of space here, let's go down a bit. The order of the product matrix, that is the answer, is given by the number of rows in A and the number of columns in B. So it's given by rows of A, by the number of columns in B, and again the easiest way to picture that is the order of A, and you already had to write this for any matrix to check if you can do the multiplication anyway, m times n, n times p. The m and the p, the outside values, when you write the orders, gives the fact that m times p is the order of the answer matrix. So if we go back to this, I had n and p, rows by columns. This is a 2 by 2 matrix. This is a 1, 2, 1, 2 by 1 matrix. These 2 are the same. Oh, wow, sorry about the bell. That's going to keep going, isn't it? Those 2 are the same. We can multiply them. These give me the order of the answer matrix, 2 by 1. My answer matrix, 2 rows, 1 column. Fourth rule, A times B is not the same as B times A. I can do this matrix times that matrix. I can't do that matrix times that matrix. Even if I could, the answer would be likely to be different. Normally in maths, I can multiply in either order and get the same answer. In matrix multiplication, it doesn't work like that.